differentiate r of t equals t squared plus 2 all over t to the fourth minus 3t squared plus 1. This is another one where we'll need to use the quotient rule, and there's a lot more going on here. There's going to be more terms that we'll have to deal with, so we want to be careful. Just a reminder, the mnemonic for the quotient rule is low d high minus high d low all over low squared. So let's start dealing with all of this. If we want our derivative, we're going to have the lower function, which is t to the fourth minus 3t squared plus 1, times the derivative of the higher function. The derivative of t squared plus 2 is just going to be 2t, minus the higher function, which is t squared plus 2, times the derivative of the lower function. When we differentiate t to the fourth, that gives us 4t cubed, and then minus the derivative of 3t squared is 6t, because the derivative of t squared is 2t, times 3 is 6t, and then the derivative of a constant is 0, so that's all we have up there, all over the lower function squared, t to the fourth minus 3t squared plus 1, all squared. Good. Now, in the numerator, we have a lot of things we need to do. We need to start by distributing that 2t into the first set of parentheses. So this is going to give us 2t to the fifth when we multiply 2t by t to the fourth, and then minus 6t cubed plus 2t, minus, we've got a product of two binomials, so we're going to FOIL that out, and then we're going to distribute that subtraction sign. So when we multiply the first two terms, that gives us 4t to the fifth, and then the outer terms is going to give us minus 6t cubed. The inner terms, it looks like we're going to get 8t cubed. And then the last terms is going to be minus 12t. And this is all over t to the fourth minus 3t squared plus 1, all squared. Now we need to distribute that subtraction to all of the terms in the brackets. We still have our 2t to the fifth minus 6t cubed plus 2t out front. But then when we distribute that subtraction, it's going to be minus 4t to the fifth, and then plus 6t cubed minus 8t cubed and plus 12t, all over t to the fourth minus 3t squared plus 1, all squared. And then it looks like we've got like terms in the numerator. We've got some t to the fifths, we've got some t cubeds, and we've got some t's. So let's go through and combine them. The t to the fifths, 2t to the fifth minus 4t to the fifth, is going to be negative 2t to the fifth. When we look at the t cubes, the negative 6t cubed and the positive 6t cubed cancel, and we're just left with that minus 8t cubed. And then the t terms that we have, we've got 2t plus 12t, which should give us 14t. And this is all over t to the fourth minus 3t squared plus 1, quantity squared. Now, in the numerator, we can factor out 2t. I'm actually going to factor out negative 2t just to give us a leading coefficient up there that's positive. So when we factor out a negative 2t, that's going to give us t to the fourth, and then plus 4t squared minus 7, all over t to the fourth minus 3t squared plus 1, all squared. And it doesn't look like there's anything that we can factor out of those that's going to cancel nicely. In fact, those don't look like they factor over the integers at all. So there's no canceling we can do, so this is what we end up with. And just a heads up, oftentimes when we're taking the derivative of a complicated rational function where we've got a lot of terms in the top and bottom, we're going to end up with a derivative that has a lot going on. And maybe sometimes we'll get lucky and some things are going to cancel, but sometimes it's just going to look like this.